Today we are going to discuss a paper titled as the Big Data Newsvendor, Practical Insights from Machine Learning. The paper got published in the year of 2019 in Journal of Operations Research, and it was authored by Ban and Rudin. The main concept of the paper is around the demand distribution using some big data. And last class, Balaganesh discussed the demand distribution estimation using unobservable features from the demand data. And in that paper also he mentioned that there are papers which talk about this observable feature used in demand distribution. So this paper is basically about that. The paper investigates the classical news vendor problem when the decision maker has n past demand data and also a large feature set which is related to demand. So P is the feature set, large number of P features, and using this features we can better estimate the demand. The features can be, the examples of the features can be customer demographics, weather forecast, seasonality, and also economic indicators. When we have this kind of feature in our data set, we can use some machine learning models that is given in this paper to better estimate the demand, and which will help the manager to make a better decision in the future. When we talk about the literature review part, the main contribution of this paper to the literature is in three areas, which is discussed in the paper. Which is, the first one will be the data-driven inventory model. The second one is the performance bound analysis of data-driven inventory decisions. The third one will be the high-dimensional quantile regression. I'm not going into the detail of the literature review part. We'll keep our discussion around the managerial insights that we get from the paper or the research. Coming to the news vendor problem, the main concept lies where we want to minimize the total expected cost, and total expected cost is nothing but a function of Q quantity that we are going to order and the demand which is unknown to us. So basically we want to minimize the expected cost, which will be our main objective for a news vendor model, and this is discussed in this equation 1. When we just expand this equation to equation 2, says the equation 2 gives the expanded version of this equation 1. So there are two costs involved, which is B is the back order cost per unit and H holding cost per unit, and this is the total cost that we will get from this. Here this plus symbol shows that it's max of 0 comma Q minus D. So when this term becomes negative, when the demand is greater than the order quantity, we will not be having any leftover quantity, and so that becomes negative, and so it will be 0. So basically we will not be having any kind of holding cost. So similar to this term can be 0 as well. So this is the main equation of objective equation of the news vendor model, and when we apply some classical optimization technique and we know the demand distribution, so we can find the critical fractile. Last time we discussed in the class, that is B by B plus H. It is nothing but the underage cost by summation of underage cost and overage cost. Now this is the classical formula for news vendor model, and when we take it forward, like take it to another level of data driven news vendor problem, we have n period data, and how can we use it to better estimate the demand when we don't know the demand distribution, or we can't estimate the demand distribution easily. So what the paper says that first we can take the sample average approximation kind of method, which is denoted as SAA. It's nothing but we'll take each period demand, which is period I is denoted as a period. So for each period demand we have Di as the demand, and we get the total cost for each period. And when we take a sample average by dividing it with the number of periods n, then we get the minimize that objective function which we need to be minimizing. And this SAA decision we can use to estimate the order quantity. So Qn is the estimation. The hat symbol says the estimated minimum order quantity. So this is the first approach. Now going to the next approach, where both demand and features are available to us. So here, so the features that we discussed in the first part, that weather forecasts, location, economic indicators, seasonality, those are the features associated with the demand. So not only demand is available to us, demand data is available to us, but also we have features that are connected to demand also with us. So how we can use those features to improvise our demand estimation. So the features are denoted as this small x, which is a which is an element of this feature space capital X, and this is a subset of real number. And this function is now, this expected cost function is now conditional on the feature vector. So there are two elements to it. One is demand conditioned on the feature. So decision maker intent on finding the optimal order quantity in this new setting has three issues to address, that is given in this paper. So now we have two sets of data. One is the feature and one is the demand. For each period we have feature and demand. So data may be low dimensional or high dimensional. This is discussed in this paragraph. So low dimensional when the number of features is small compared to the number of observations n, and high dimensional when it is the opposite to it. So when the number of features are larger than the number of demand data. Now coming to the algorithms that the paper discusses. So there are two basic algorithms that the paper discusses. One is the empirical risk minimization algorithm. So here the paper says that we want to minimize the empirical risk associated with this kind of demand estimation, which is given as the Newsvendor ERM in a short form. So NVERM is the first method they are talking about. So when we have a demand data along with features, so our quantity that we are going to order will be the function of this feature xi, and this r hat is called the empirical risk of the function q with respect to the data set Sn. So data set is Sn, and we have this r as the rq, the empirical risk that we want to minimize. So the first algorithm, that's algorithm 1, that is given in this this page, where it says that ERM algorithm 1, here we are actually minimizing the risk associated with this data set Sn, and this is nothing but 1 by n, this is average b into per each period demand minus q with feature set xi and plus the holding cost, and this di minus qxi is now shown as ui and ui, and this qxi minus di is shown as oi. So these two things we want to add to the cost, and actually the underage cost and overage cost, and we want to minimize the risk associated with this. So these are the constraints. The first constraint says that our underage and overage costs should be greater than this di minus q1. Q1 is nothing but the first period demand, where in the first period they are saying that for the first period they are saying that we can take that as 1. Here they have written where x1 equal to 1 to allow for a featured independent term for the first period. So this is a kind of intercept term. Now coming to the second part of the algorithm, which is the ERM algorithm 2, they have added a regularization parameter to it, which is nothing but taking the regularization parameter lambda and this norm of the vector. This norm of the vector q. Q is the feature dependent quantity that we are going to minimize. So this norm of the vector is nothing but the length of the vector. So L1 norm will be first normal length of the vector, which is just summation of all the vectors that is available in that set. L2 norm will be the Euclidean distance kind of thing. So here they are talking about LK norm of the vector q, k it is written as. So in case of L2, the norm problem becomes a second order cone programming, which will be easy for us to solve. Next method that the paper discusses is called the kernel optimization method. So they are proposing a new approach, an alternative approach, which can take features into account and estimate demand distribution. So it is based on a non-parametric regression technique. So one of the goals that the paper discusses that non-parametric regression has is that expectation of dependent variable. So better estimate the expectation of dependent variable, which is demand over here, and this dependent variable is conditional on the independent variables, or the independent variables are the features of the data, so the demand. So here we are just estimating this expectation of y, which is conditional on xn plus 1. Y is the dependent variable or the demand, xn plus 1 is the n plus 1 periods feature vector. So the proposition 1 says that we are actually going to estimate this qn, which is also taking a parameter k. So this kernel function is kind of a kernel technique is a kind of a functional method which talks about this kernel function, which is a method used to take data as input and transform it into the required form of processing data. So when we don't have proper data for features, for example, and it's in a scattered form, and we need in a pre-processing stage, proper pre-processing stage, then we use this kernel function to make it in a proper pre-processing phase. Now this equation 8 says that we can find this qn by ranking the past demand in an increasing order and choosing the smallest value at which this inequality 8 is satisfied. So this is the basic concept behind this kernel optimization technique. Now going to this next part, here the paper discusses the comparison of their work, the authors discusses the comparison of their work with other inventory papers. So they also say that they are not the new those who are doing research in this area where big data is used to estimate the demand in Newsvendor model or inventory models. So there are other papers and they are just discussing how their paper is similar to them or better than them in estimating the demand. So they have given some comparison. Next which is there is that they have taken two examples of demand, and using this demand model, how their model is better in terms of estimating demand, or they are theoretically proving all the parameters, all the theorems that they are proposing. So this first example is a normal two population demand model, and the second example is a linear demand model. Now so they also say that in theorem 4 that how cost difference is there when there is normal Newsvendor decision is there, and the expected cost when they are saying that the big data used estimated order quantity, which is q hat, and q star is the normal optimal order quantity. They are saying that there is a cost difference, and they are in a case study they are also showing the cost difference, how managers can use this big data technique to estimate demand in a better manner and save cost. So now coming to the last part where they discuss the case study, which is the main idea of the paper, where they take an empirical technique to prove, or take a benchmark data to prove that their model is better in terms of estimating demand and saving cost. They have taken a nurse staffing in a hospital emergency room. So they are applying this learning algorithms in different forms and finding that our this optimization technique that they are using to estimate the demand is giving them a proper demand, and that is helpful in saving cost. Then that also then the discussion of the results, they are showing that their technique is this kernel optimization technique with operational statistics is giving actually improvement of around 24%. The next best one was the Newsvendor regression one, that the first empirical regression technique, that is risk minimization regression, that is also giving around 23% cost saving. So the cost saving was huge, because this we can say that around 46,555 euros have been saved by using this technique, this kernel optimization technique with operational statistics. And this optimal staffing decision is basically a challenging area in any hospital when we talk about emergency nurses deployment. And also in the conclusion part, they are saying that it is not the only method that they have discussed in this paper which will be helpful for estimating that. There are other multiple methods which will be also applicable in this area, and it also depends on the data, that what kind of data you are dealing with, and using that also you can check which method is actually suitable for your data and which will be giving you a better estimate. So big data driven decision maker always should check which method will be helpful for him or her to actually optimize the demand distribution estimation. So here they have given this graph where this dotted line shows the estimated demand from the optimization technique, but kernel optimization with operational statistics, and actual is shown in the blue line. So they are saying that mostly they are following the proper pattern, and the estimate is quite nearer to the actual data. Both the techniques can you see. First one is the kernel optimization of the operational statistics. Second one is the NV Newsvendor regression with operational statistics. So operational statistics, if they have, that is giving them better estimated demand. So this is the end of the paper, which talks about the case study. Thank you.